you've been given that capital F of x equals this integral, and then you've been asked to find f prime of x. So as soon as you're taking the derivative here, you're also taking the derivative here, and the derivative and the integral are canceling out, the fundamental theorem of calculus, leaving the limit plugged in, x times cosine of x. Because the lower limit is a constant, when you take the derivative, this inner function, the derivative of that inner function, will be 0, so we're subtracting off nothing. When you take the derivative of the upper function, the derivative of x is 1. So I'm really multiplying all of this by 1, but you would never write that. So my final answer is here. Similarly, we've got f of x equaling the integral from 0 to sine of x of square root of t, excuse me, I've written this down wrong. And we're going to take the derivative, so that means we're going to take this derivative, and these will cancel out, leaving just the square root of t, but for t we're going to plug in our upper limit, sine of x, and we need to recognize that the upper limit will now have a derivative. So instead of multiplying by 1 in the first example, now we're multiplying by the derivative of sine, cosine, and that's again because of the chain rule. We said we were going to take a derivative, and this upper limit will be our inner function minus the derivative of 0 will be 0, so I don't have anything there. Same as the last time, the derivative of f cancels out the integral that's there, and so I will put my upper limit in, but I also have to multiply by the derivative of that inner function, 2x. I will put my lower limit, negative 2x. The derivative of negative 2x is negative 2. Recognizing that two negatives make a positive gives you your final answer.